So, good morning, everyone, and welcome to the Carmenta Stockholm office. It's 10 a.m. and it's time to get the webinar started. It looks as though everyone's been able to connect to both audio and video. I'm really happy to see so many of you online. I see a lot of familiar faces, but also some new people. So I really hope that you'll enjoy this little show that we've prepared for you. So the topic for today is all the new features that we've been adding over the last few months to our core product, Carmenta Engine, and that will be released as part of the upcoming 5.14. And I'll get, of course, much more into detail on both the release schedule for this version and also the new features in just a little while. So let's get started here. First of all, for those of you who don't know me, my name is Tobias Moberg. I'm the head of product management at Carmenta Geospatial Technology. So I'm sort of responsible for this awesome little product suite that we're producing, and of course also for the roadmap in the months and years ahead. So I spend a lot of time usually talking to customers like you to figure out what kind of functionality we should prioritize and add in upcoming versions. So it's really good to meet you all. I thought before we start, we can just have a quick look at the agenda and how I'll try to structure these approximately 30 minutes or so that we've got planned for today. I'll start, for the new ones in the audience, I'll start with a very brief intro to our geospatial technology on a slightly higher level. It's just 2 slides where I'll try to explain what it is we do and how we package this technology. Then we'll dive into the new features, and I'll do this by giving you a very hands-on look. In fact, most of the demos I'll show you, they're just the included programming samples in the new version of the SDK. So once you get your hand on the new SDK, you'll be able to play around with the same functionality yourself. We'll wrap up with a little Q&A session, and there is actually functionality for this in Zoom. So if you have a look in your Zoom client, you'll find a button called, appropriately enough, Q&A. If you click that, there's a little chat function in there where you can ask questions. And feel free to do that during the entire webinar. But then when we get to this Q&A session at the end, I'll have a look at the questions that's come in, and I'll address as many of them as possible during the actual webinar. And the ones that we don't have time for, we will address via email later on, so they're not wasted. Yeah, so if you see interesting stuff, I mean, of course, it's hard for you to interrupt me during the actual presentation, but make sure to ping me in the Q&A, and I'll try to address all your questions later on. Okay, so that's all the formalia for today, so let's just jump right into it. What is it we do at Carmenta Geospatial? Well, I like to put it like this. We create technology that helps you visualize and analyze geospatial information. And when I talk about geospatial information, I'm not only referring to the static data, the background maps. Quite the opposite, in fact. Our technology is designed to handle both all those different backgrounds, but also all the dynamic information that you want to put on top of your map, such as, say, a live video stream from a drone, or radar video from a radar installation, or positioned vehicles via some communication link. We are very good at bringing all that geolocalized information together to create a combined display where you can make sense of all this information. And on the topic of making sense of it then, it's not only about visualizing it, rendering it to the screen. We're also doing quite a lot to help you make sense of what's going on in the map. So we're providing various kinds of analysis, and you'll see some examples of that as well in this presentation. And all these analyses, they are designed to make it easier for your end users to make sense of what's going on in the map. Another key differentiator when it comes to Carmenta is that we have designed our technology from the ground up for what we usually call the mission-critical use case. So we're used a lot in systems where, well, the map and the application that has the built-in map, it simply cannot fail. Be it the dispatch system for handling incoming emergencies and dispatching ambulances, or be it a battle management system inside an armored vehicle, or maybe a sensor data display in an aerial surveillance aircraft. In all these scenarios, you really have to be able to rely on the map It has to be performant, and it has to be really stable. So that really influences how we design our product suite. We spend a lot of time ensuring that it has the required stability and performance to meet these high demands. Briefly, our different products. The main product, or the core product in the product suite, is what's known as the Carmenta Engine. And of course, this is the product we will talk most about today. So Carmenta Engine is a so-called SDK. It's a software development kit that allows you as a developer to integrate functionality into your own application. It's available on a wide number of different platforms, and you can use it from many different programming languages. So we try to be very open in how you can actually integrate our technology. If you're not looking for an SDK, but rather want to use the functionality that we provide through a service interface, then we have another product for you, which is the Carmenta Server. It's a sort of encapsulation of the same core technology, but rather than providing APIs, then it provides standardized interfaces, web interfaces or HTTP interfaces to the functionality. There's a version of the Carmenta Server which is provided as a so-called Docker container for easy deployment in those kinds of architectures. It's called Carmenta Server Core. It was released last year, and we've seen a lot of interest in this packaging of the server technology from our customers. Okay, so that's enough about who we are and the products we provide. I know that's not why most of you came to this webinar. So let's dive into the more details then. The new features in the upcoming 5.14 release of Carmenta Engine. I should maybe say a few words about what this release status is of this new version. As you're probably well aware, it has not been released yet. A few of you I know have been participating in pre-release programs. So we're actually getting very close to release. It's currently undergoing final testing. I sort of expect release to happen within a week or two. Could be a bit longer depending on how the final testing is going. But we're almost there. And I'm using one of the most recent release candidates to run this presentation today. So jumping into the presentation then, new features. Well, this is one of the new cool things that we did. We allow you now to use video streams from your drones or surveillance aircrafts and geolocalize them and draw them directly onto our 3D maps, our globe view maps. You might be familiar with this functionality, the georeferenced video. The so-called camera project operator has been around for a few years now. But the new thing is that you can now sort of beam or project the video directly onto your 3D scene. And conceptually, you can sort of think of this in the same way as our 3D line of sight analysis, where we, on the graphics card level, we sort of beam the rays from the observer onto the ground. We're doing more or less the same thing here, but rather than beaming a solid color, we are beaming a video stream. And that means that you can actually render this video onto any kind of 3D environment, be it a basic model created from elevation data or a detailed 3D city model. I'm going to show you a sample of this. And it's actually one of the samples that are included in the SDK. Let's get that started here. So some of you might recognize this sample. It's the projected video one. It's a C++ Qt application that has a little demo video here that it's displaying in a 2D map, overlaying it on top of the raster and vector data like this. So what has happened in 5.14 is that we've added a new little button to this sample called 3D. So I'll just switch to the 3D presentation. So you can see we're still in the same area here, but we have a 3D environment that's built up from both the orthophoto, the vector data, and then some extruded building outlines here. So let's start the playback of the video in this 3D environment. Well, as you can see, I'm actually gonna change the screen sharing so that it's optimizing the frame rate a bit more. So I hope you now can see sort of the frame rate that I'm getting in this presentation. We're playing back the video. There's a little cone up here indicating where the drone was positioned. And then we're playbacking the video right onto the 3D environment here. And you can see that it's not only rendered onto the ground here, it's rendered also onto these buildings that we've extruded. There's, of course, a shadow that the building is cast here where there's no video. And this is all done on the graphics card level, so it's a very efficient operation. It doesn't use the CPU a lot, and it's really easy to use. There is a new overlay class for the globe view called the camera project overlay, and it's used and it accepts the same inputs as the existing camera project operator. So this is something that's really easy to integrate into your 3D globe view map configuration. So yeah, that's one of the new features. Just going to start up another little sample here, like so, and that will allow us to move to the next new feature then. So another big thing we did in 5.14 was to introduce something that we call volumetric line of sight. And this feature actually consists of two different components in the engine. The first thing that we did is that we extended the existing line of sight operator with the ability to generate a new kind of output. So rather than just generating a raster output, which you can visualize on the ground to indicate what you can see, it can now generate so-called viewshed volumes. And I'll show you in just a second what that might look like. These volumes that the line of sight operator can generate, you can use them to present them in a 3D view, of course, but you can also intersect them in various ways. You can, for example, use them as input to a vertical profile operator to cut through the volume that is seen from the observer and see which areas of the vertical profile route actually intersects with the volume. You can use the isoline operator to make horizontal cuts through the volume as well, if you want to present that in a 2D map display. But in addition to this feature in line of sight operator, we've also done a new operator called the airspace coverage operator. And what it does is that it merges a number of these viewshed volumes within a specified airspace of interest. So it gives you an easy way to figure out how much of this airspace am I actually covering with my observers. This might sound a little bit tricky to understand, so let's just have a look at a few examples of how this functionality actually works. So I've opened up a 3D configuration here. I guess you notice or recognize the area here if you're a Carmenta Engine user. We're in Lake Tahoe in Northern California, where most of our sample geodata for Carmenta Engine is located. So it's a 3D presentation, of course, using some high-res imagery to texture the ground. And you can see that in the middle of the map here, I've got a little observer, like the observers in our regular line of sight sample configuration. So say that I wanted to know what this observer can see. Well, the traditional way of doing that is to drape the result of the line of sight analysis onto the surface like this. So as I'm moving this object around, you can see that we're updating and we're looking at what we can see from that position. But of course, looking at it in a 3D environment like this, it's quite clear that it would be interesting to visualize this in another way. Say that I'm an aircraft overflying this area, and I'm interested to see what areas do I need to avoid. Well, we know that there is a maximum range of this observer. So of course I can start by just visualizing the maximal range like that. If you're an experienced engine user, you will know that this is the sphere operator that's generating the structure, and we'll just visualizing that in a wireframe way here. So this gives me some sort of idea that this is the area which is sort of dangerous. But what part of this area is really dangerous? What is within the line of sight? Well, that's where the volumetric line of sight comes in. So I'm going to enable another layer here. This is the same line of sight operator that I was using to colorize the ground, but I've now configured it to output volumes instead of rasters. So I'm getting a volume, which I'm visualizing in a sort of semi-transparent fashion here. And as I move the observer around here, the volume will be recalculated. And this is where it gets interesting, because you can see here that this is the sort of maximum range of the observer. So this is the dome here, but there's part of the dome down here which is not really covered by this red blob. Well, it's of course because this is the area where I would be hidden from sight from that observer, right? So if I were to plan a military operation here, for example, this is the kind of information that would make it much easier to figure out where in the terrain that I can move around here without being seen by that observer. So the ability to visualize the line of sight result as a volume can come in really handy in these kinds of use cases. But I also mentioned that we had another operator that can do airspace related things. And this operator is called the airspace coverage operator then. And I'm going to give you a demo of that one as well. So let's turn off that single line of sight. And then you can see we got a couple of other observers over here. And the reason for that is actually that I've defined an area of interest over here. So this yellow fence you can see here is the defined area of interest for our airspace coverage operator. So I've got two different observers placed around the lake here. Well, why not move our third observer over to this region as well, so it can also join the analysis. So we've now got three different observers placed around the lake. This one, and this one, and this one. So this is the ideal coverage or maximal coverage of these observers. But are they actually covering the entire area of this airspace? Well, this is what the airspace coverage operator can tell us. So the areas which you see now, which are colored in red here, it's not the visible areas, it's the opposite. It's the areas where I have no coverage from these observers within the defined airspace. So if I start moving these observers around, you'll see that the analysis result, it updates. I'm moving that one in as well, and now I have a pretty good coverage, but due to the mountain here, there are areas over the lake here which I can't see. So maybe we'll want to move this one in a bit closer, for example. So this is an example of the airspace coverage analysis. It can actually do more things than just tell you where you don't have coverage. Based on a number of different observers, it can tell you where you have coverage that is good enough, meaning that you have coverage by an enough number of observers. So just for demo purposes here, I've set up a layer which visualizes the dual coverage. That is the areas where I have coverage with at least two different observers. So we've got this one over here and this one over here. So the green blob here is actually the intersection of these two maximal coverages. But of course, it doesn't include the areas down at the lake here where I didn't have coverage due to the surrounding terrain. So that's a little example of the airspace coverage analysis. So another new feature we've added is what we call feature animations. And this is a new API on the memory dataset class. Memory datasets are typically used to handle application data. So this is where you put and you update your dynamic information that you want to overlay on top of your map. And there's now an API which allows you to easily animate features in the memory dataset. You can, for example, set them to move continuously along a certain direction and speed, for example. But you can also animate their transitions from one point to another. And of course, there's a sample included of this in the new SDK as well. So I'm going to go ahead and open up that sample. I'm still keeping the frame rate optimized sharing on so that you can see the sort of frame rate on this animation. But I hope that it's not too blurry on your side. So this is the feature animation sample that's included in the SDK. It's maybe not the prettiest application you ever saw, but it's pretty sort of illustrative of the new API. So using the panel on the left here, you can trigger both the so-called move to functionality, which smoothly moves an object from one position to another. And you can use the various animation methods that continuously moves an object, either in a 2D space or a 3D space. So starting with the move to object here. For moving an object, you specify a duration and then an animation function that will be applied during the move. So here, for example, you can see that the helicopter now moves around between some hard-coded points. And it moves rather smoothly. And it's using this ease in out function then to sort of change the speed along the path of movement. So this is just a one-liner in the API to get your features to move smoothly like this, rather than jumping from one position to another. We could try out the animation support as well. So here you get a view of the different parameters for specifying a 2D animation. So right now this helicopter, it's moving and it's changing its course over time, because you have the possibility to specify delta values for all the different movement directions. We could do an animation in 3D as well. So if we start looking at the 3D map here, you can see that the helicopter is now also continuously moving, but rather than just moving in the 2 dimensions, it's also changing its pitch and its roll and so on over time. So this is another overload of this animate feature method on the memory dataset. So we've spent a lot of time ensuring that, that these methods are really efficient, that they have as low overhead as possible. They interact very nicely with our different cache modes on the ordinary layer. So we've really done what we can to give you as good performance as possible when you do these animations. So we think in most cases, introducing this kind of smooth movements of features in applications will lead to almost no performance slowdown. Okay, so moving on then to another new feature. You can now use Carmenta Engine to create packages in the standardized OGC GeoPackage format. OGC is an organization that a few of you might be familiar with. It's the Open Geospatial Consortium. So they're in the business of standardizing interfaces for exchanging geospatial information over the web mostly. But they've also created this very nice file format, which we've supported for quite a long time in Carmenta Engine. It's a SQLite-based container, so it's a single file format where you can store lots of different geospatial information. And we've added a brand new API in Carmenta Engine 5.14 for programmatically adding any kinds of data to a GeoPackage, both image data rendered by the engine, coverage data, such as elevation data or land classification data, and also vector data features. They are now really easy to write to a package using just a few lines of code. We could actually have a quick look at this API since we seem to have a little bit of time. So the API is called the map package. So I'm jumping into the SDK documentation now, and now maybe it's time to turn off this frame rate optimized video sharing. So now hopefully you can read the text. So I'm jumping into the map package class and its members. So essentially you construct a map package with the path to the GeoPackage that you want to write. And then there are creation methods for creating different kinds of writers. For example, writers that will write image data to the GeoPackage. They're called pyramid writers because the data that will be written to the GeoPackage is actually stored in a tiled fashion and in multi-resolutions to ensure that it's quick to access in any scale level. So for creating image data, you can either pass in a view or a layer, as you can see here. And we can have a quick look at some sample code here as well. So this is essentially what you would do to create a GeoPackage and save the contents of an entire layer to it. I can make it a bit bigger here maybe. So as I said, you'll construct the map package with your file name, and then you define a so-called image table with some metadata for how the data will be stored. And then finally, you create your image writer and call its write method. There's also an API for getting progress from these writers. So it's possible to implement this in an asynchronous fashion where you display a progress bar while the data is being written. So as you can see, a very easy to use API that makes it easy to create these standardized GeoPackages that you can then easily distribute to your own Carmenta-based systems or to systems from other vendors which also support this standardized file format. Okay, moving on. What else do we have in store? Yes, on the data format side, we've also added support for another data format called the Aeronautical Information Exchange Model, or more commonly known as AIXM. So this is an XML-based format that's used to represent aeronautical data. It's similar in concept to the ARINC 424 format, which we've supported for a long time in Carmenta Engine. So this is encapsulated in just the way you would expect. There's a new dataset for this, the AIXM dataset. It connects directly to this kind of XML file. Just like the ARINC 424 dataset, at first initialization, it will build a very efficient spatial index of all the features in the XML file. So it will be very quick to retrieve the features once they've been indexed. We also support the time slicing functionality that's part of AIXM. So it's possible to tell the AIXM dataset to pick data for a specific time slot. So I'm opening up one of the sample configuration files here now. This is a file that reads directly from an AIXM file. And you can see we apply our visualization to make it look more or less like a paper en route chart. And that's all done on the fly as the data is being read. So AIXM support, another new feature in 5.14. What else did we do? Well, we added support for new tactical symbol standards. We're now moved to the D or Delta versions of both the American MIL standard 2525 and the NATO AP6 standard. So this is, of course, part of the tactical extension. It does not replace our previous support for the B and C versions of these standards, but rather extends it with new functionality. In 5.14, we support the punctual or point symbol graphics from the D versions of these standards. On the roadmap for the upcoming version 5.15 is to also have full support for the tactical graphics in these new versions. And that will bring feature parity then with our current implementation of the C versions of these standards. Another new feature concerns our support for visualizing raw radar data with the radar video layer. We've added support for supplying a custom or user-defined color table to the radar video. And this is commonly used when presenting data from a weather radar. Here's an example from a little sample app we built internally at Carmenta. It's presenting openly available historical weather data from NOAA, the American Weather Institute. And as you can see, we're applying a custom color table here to go from blue to green to eventually red here, depending on how much these sweep values, how high the values are essentially. And this is the type of display meteorologists typically expect when they're looking at weather data information. So a little new tweak to the API. Of course, conceptually, this works exactly like it did before with the radar video layer. It's just the ability to supply this custom color table that is new. Another thing we did, and this is the last little demo that I wanted to show you, is that we made it possible to work with the hardware accelerated effects concept also on the 3D overlays. So remember, 3D overlays, it's, for example, the 3D line of sight or the surface overlays or the georeferenced video that I just showed you that was new. And And the effects, well, they were introduced a few versions back, and they make it possible to let the graphics card enhance the presentation of certain map layers. So being able to do this with the 3D overlays is, of course, very convenient. Let's have a look at what you could, for example, do. I'm going to open up the configuration file for the projected video sample in Carmenta Studio. Remember when we saw the video in 3D, it was almost a little bit difficult to see exactly where the video ended and where the satellite image started. So I'm going to go down now to the globe view. You can see here's the camera project overlay that displays the video stream. I'm just going to enable a little effect on this one. I'm going to go in and add a halo effect. I'm going to modify that a little bit. Maybe we want a yellow tint. Let's say 4 pixels around the video should be enough to delineate it a bit. So I'm saving this, and then I'm restarting the projected video sample, and we'll see if we can see a difference. And I'm once again switching to this FPS optimized screen sharing to hopefully let you see the frame rate of this application. So we're switching back to 3D. Oops. Let's see if it starts loading the buildings and stuff. And here you can see, we now get this delineation of the video. If I start playing it again, you'll see it's now much easier to see where the video, for example, is shadowed by the building here, for example. And since this halo is applied on the graphics card level, again, it has almost no impact on the performance. So I still get the full frame rate when displaying this video in the 3D view. Okay, so we're quite proud of what we've been able to squeeze into this new release. There's a lot of new features. There's even more things, of course, that I don't have time to go into detail on in this presentation. For example, there's a new, very convenient functionality that lets you catch map update layers on a map update errors, I should say, on a layer level, so that you can disable only a problematic layer rather than having to sort of stop the entire map rendering and handle the exception on a view level. It's called Disable on Error. It's very easy to use. You just turn that on and we will take care of encapsulating those errors. There's a new little API on the drawable, the renderer settings, which makes it possible to configure the hardware accelerated rendering for greater fidelity. You can, for example, configure how many pixels will be used for multi-sample anti-aliasing. And there's an operator which sorts features, called, appropriately enough, the sort operator. Can come in handy sometimes when the drawing order is more important. And finally, behind the scenes in the map controls, there's now a new scheduling mechanism, which ensures that when you have multiple map controls in your application, you will get a much more evenly distributed frame rate among those map controls. And the scheduling mechanism also tries to ensure that the application UI stays as responsive as possible. Okay, so that's the end of the list of new features, and I hope you sort of saw at least some features that you liked and can see a use for in your applications. A quick note on some system requirements changes in version 5.14 before we wrap up. We've done a version leap on the Linux side. So for Red Hat, we now support versions 7 and 8. For Ubuntu, where we target the long-term support versions, we're now at 18.04 and 20.04. And for the SUSE Linux, we're moving to version 15. For the Android version, the new minimum version is 6.0. But we're pretty sure that this will not affect any of our Android customers. You're all on newer versions than that. There is also a new minimum Qt version for C++ UI development that we're testing with. It's version 5.9. It's now the minimum version for our Qt map control. We're not restricting you from using older Qt versions than that, but this is what we're testing on for now on. Another little info point here before we wrap up. We have some planned system requirements changes for upcoming versions. Carmenta Engine 5.14, so the version that we will release now, will be the last version that supports Windows 7 and Windows 8. So the upcoming Carmenta Engine 5.15 will be Windows 10 only. And we're also very much in the process of phasing out the 32-bit version of Carmenta Engine. We have not yet made a firm decision on whether 5.15, so the version after this, will be offered in a 32-bit version. We're very interested in hearing feedback from you guys on that, on whether you still have a big need for the 32-bit version of the SDK. So please get in touch with us there, and we'll also probably send out some sort of survey to gauge the interest there. Okay, so that's what I had on the final practicalities level, and sort of that wraps up the presentation. So let's see then, are there any questions that's come in during the presentation? Yeah, okay, so let's see. There's one question about the video overlay in 3D and what kind of GPU requirements it has. And it's hard to give a definite answer for that, but the added requirements of the video overlay in 3D are very modest, I should say. I can mention that I'm running this whole webinar on a 4-year-old Dell XPS 13 computer with no dedicated graphics. So I've got an old generation Intel HD graphics on my machine, and the 3D overlay runs just fine. Typically, there are other aspects of your 3D configuration that more determines the GPU requirements, such as if you're wanting to use really detailed 3D city models with lots of polygons, that will put some requirements on the GPU. But this is a very efficient little shader that's running, and it runs also very well on just Intel HD and similar non-dedicated GPUs. So I hope that addressed that question. Let's see. Okay, there's one more question about the radar demo that I showed on whether that weather data is included as part of the SDK. Yeah, that's a good question. Actually, no, it isn't. The sample data for the radar video layer is still the same as it was in previous versions. But of course, we'll happily share the source code for that sample, showing you how you can bring in that NOAA weather data into your own application. I'll look at how we can somehow publish that. But if you saw this webinar and you're interested in that code sample, then feel free to give us a ping and we'll happily send that over. Okay, those were the questions that came in. Okay, so there's now one. I'm glad that you're still awake out there. There's one more question that came in, and this question concerns the format, the input formats for the video overlay. And the answer there is that we do not include any video decoding functionality as part of Carmenta Engine SDK. Instead, we provide an API where you can feed us the decoded video for us to handle and display. And we include a programming sample. It was actually the sample that I just showed you. It's a C++ sample that shows you how you can use FFmpeg to decode video streams and then pass it from FFmpeg into Carmenta Engine. So that's one way of doing it. We also, in that sample, we have sample code for implementing the relevant NATO stanags for decoding georeferenced video. And you can read more about this in the documentation for that sample, and you're free to use that sample code as a basis for your own video decoding code. Okay then. So now I think we're at the end of the questions here. So happy to see that you, as I said, managed to stay awake all the way to the end here, since there were some late incoming questions. So thanks a lot for listening today. I really hope that you found this interesting. And that, as I said, that you found some features in 5.14 that you think can be useful in your application. Feel free to get in touch with us, of course, via our homepage or the info address, or feel free to get in touch with me directly. I showed my email address there earlier. It's tobias.moberg@carmenta.com. We're always happy to hear from customers and potential customers, always happy to discuss potential new features in our SDK. And remember, if you see a use case for Carmenta Engine in your application, We have evaluation versions available. You can just get in touch with us via the web page, and we'll happily send you an evaluation version so that you can try this out in your own solution. So with that, thanks for listening. Time to wrap up, and have a really good day and a good weekend. See you all. Bye-bye.